So in today's class, we'll be looking at some of the nth terms of an AP or an arithmetic progression. So we have discussed earlier that the nth term of an AP is given as Tn equals a plus n minus 1 multiplied by d. So we want to look at the sum of the nth terms. That is the aspect of series. Now we have looked at the aspect of sequence. We're now looking at the aspect of series in which we had the terms together. So sum of the n terms of an AP. So without wasting much of time, the sum of the n term of an AP is given as. So we have this. So the sum of the n term of an AP is given as this. So the sum of n term, that's Sn, is given as n over 2 into a plus l. Remember, for an AP, a is the first term, then n is the number of terms. So l here is serving as the last term. So and it's given as this. The last term has the same expression as the nth term. So if you know the first term and you know the last term, we can use this expression to calculate the sum of the terms in the sequence. But in case we don't know the last term, we can use this other expression, which is the most popular. N over 2 into 2a plus n minus 1 multiplied by d. What we just did here is we plug in l into this and we simplify, so we have this. So this is the expression for the sum of the nth terms of an AP. Do you get that? Let's take some examples now. So we have this question: find the sum of all whole numbers from 1 to 100. If you look at whole numbers from 1 to 100, you notice that they will form an AP. This is what I'm saying. The first one is 1, the next one is 2, the next one is 3, next one is 4, and like that. So 5, 6. So if we continue like that, we'll see that the terms form an AP because we keep adding 1. So from here now, we have our first term to be 1. The common difference is 1 as well, so we keep adding 1. So if you look at the terms, if the first term is 1 and the last term is 100, that means we have 100 terms there. So that means there are 100 terms since we're adding from 1 to 100. So there are 100 terms. So we get the sum of the terms now. We can use the first expression. We can use this since we know the first term and we know the last term. So xn, so the xn here is n over 2 into a plus l, since we know the first and the last term, so we can use this expression. So how many terms do we have? We have 100 terms, then divided by 2. So then the first term is 1, the last term is 100. So if we should do this, we are going to have 50 multiplied by 101. So if we should do this, we will have 5050. So that means if we had all numbers from 1 to 100, we are going to have 5050. So do you get that? So we have another question here. Find the sum of the first 15 terms of the AP 45, 37, 29. Firstly, we have to establish whether this is an AP. So let's see. If I move from 45 to 37, so that's like I subtracted 8, or I had negative 8, so negative 8. So that means it's an AP. So our done now, the common difference is minus 8 because we keep adding minus 8. Then the first term is 45. So we are looking for the sum of the first 15 terms. So that means n is 15. So we write our expression for Sn. We don't know the last term here. So another way you may first find the 15th term. That is, you find T15. So when you find T15, you now use this. But instead, we can use this second expression. We have our Sn to be equals n over 2 into 2a plus n minus 1 times t. So we are looking for sum of the 15th term. That is S15 will now be, our n is 15, so S15 will be 15 over 2 into 2 multiplied by 2 multiplied by a is what, 45, plus 15 minus 1, then we are multiplying by minus 8. So doing this, 15 divided by 2 is 7.5. Then this will give us 90 plus 14 times minus 8. So this will give us 7.5 into 90 plus 14 times minus 8 will give us minus 112. So we have 7.5 multiplied by 90 minus 112 is minus 22. So when we do this, we have minus 165. So that means if we add up the first 15 terms, we are going to have minus 165 for this AP. I believe you understand. So that is for the sum of n terms of an AP. Thank you.